Hey y'all, I had a question about section 2 in 8.6. I'm not surprised that I had a question about section 2. These are some harder type problems, so I thought I'd do a couple with you. Just record it so you can come back to it and look at it as you need to. So let's try, oh, I don't know. Let's try number 1 and number 7. So my idea here is this, is don't look at all of it initially. Just look at what's inside the parentheses and think about what that means. So again, let's look at number 1 initially and look inside of parentheses. That reads the inverse sine of 2/3. So let us draw a picture to capture what that means. Okay, so the inverse sine of 2/3. I'll write this down. So here it is, the inverse sine of 2/3. Well, what is that? Okay, that is an angle. Remember that the inverse trigonometric functions deliver up angles. That is their outputs. What angle is that? It is the angle whose sine is 2/3. Okay, so if this is some angle, which I'll call theta, what this means is that the sine of theta is 2/3. Those two equations that you see there, the inverse sine of 2/3 is theta, and the sine of theta is 2/3. Those are absolutely interchangeable. They mean the same. They're just written in slightly different ways. So let's draw a picture to represent this. Excuse me. So theta is, of course, an acute angle of a right triangle, because this is trig. That's what trig does. It's about the acute angles of a right triangle. So here's the theta. And I am told in the second equation, the sine of that theta is 2/3. So let me choose opposite and hypotenuse so that the ratio is 2/3. And one way to do this is to choose 2 for the opposite and 3 for the hypotenuse. Now, you don't have to make that choice. You could make them like 4 and 6 or 1 and 1.5. I mean, anything that results in the ratio of 2/3 would be fine, but 2 and 3 are the easiest. And then what we need to find now is the sine of that, okay? Oh, I didn't realize that 1 is quite so incredibly simple. So we might actually go and do another other than number 1 and number 7, maybe 3. So what I want now is the sine of that angle, okay? That is, I want the sine of theta. That is, I want the sine of the angle whose sine is 2/3. So what does that have to be? That has to be 2/3, of course. This is highly similar to the question, what's the square root of the square of 3, right? um, there's a certain sense in which the functions undo one another. So the square of the square root of 3 is 3, and the square root of the square is 3 is also 3. They undo one another. So it's 2/3. I didn't quite realize at the start that it would be so simple. I should have. But still, my analysis, my description of what happens here is correct. So let's do number 3 now. So number 3 says the tangent of the inverse cosine of 3/5. So once again, let's concentrate on what is inside of parentheses, where we see the inverse cosine, which you know not to read as cosine to the -1, right? That's inverse cosine of 3/5. And what is that? Okay, that's an angle, because that's what inverse trig functions always deliver up. They deliver up angles. And what angle is that? It's the angle whose cosine is 3/5. Once again, those two equations are absolutely interchangeable with one another. They mean the same. Same point is made in different ways. So again, let us draw a picture. Trig is geometry of right triangles. So let us draw a right triangle. And the angle is an acute angle of that right triangle. And its cosine is 3/5. And remember that cosine is adjacent over hypotenuse. So let me choose values for adjacent and hypotenuse that will yield a ratio of 3/5. Why not 3 and 5? So there we go. And then now notice what I want. I want the tangent of that angle. Well, what is tangent by definition? Tangent is opposite over adjacent. We don't have the opposite. There's the opposite. We don't have it. So we need to get the opposite. How do we get the opposite? Well, the Pythagorean theorem, right? So the 3 squared plus the opposite squared, I'll call it, is 5 squared. Do just a tiny little bit of algebra, and you'll find that the opposite is equal to 4. So what then is the tangent of that angle? The tangent of that angle is opposite 4 over adjacent 3. So the tangent of the inverse cosine of 3/5 is 4 over 3. And then let's finally look at number 7. Number 7 says the inverse sine of the cosine of 30 degrees. And notice that this one, the order is reversed. The outer function is the inverse function. The inner function is the one that is not. But still, we ought to be able to make sense of what this is. Okay, so the cosine of 30 degrees. Once again, let's go inside of parentheses. The cosine of 30 degrees. Well, what is that? That is a ratio, okay? Because the trig function, sine, cosine, and tangent always deliver up ratios. So let us draw a picture to represent that. So here we go, the cosine of 30 degrees. So always draw a picture to represent what's inside of parentheses. So cosine of 30 degrees. So we know about the 30, 60, 90 right triangle. You're supposed to anyway. So here's the 30, 60, 90 right triangle. One way to give it side lengths is 1 for the short leg, 2 for the hypotenuse, and root 3 for the longer of the two legs. That is the leg opposite the 60-degree angle. So what we're asked is the cosine of 30 degrees. Well, the cosine of 30 degrees is, of course, adjacent over hypotenuse from the point of view of that 30-degree angle, which is root 3 over 2. And now what I want is this. I want the inverse sine. So what I want at this point then is the inverse sine of root 3 over 2. And what is that? Okay, that is an angle. And what angle is that? It is the angle such that its sine is root 3 over 2. Once again, those two equations that I just wrote, one with inverse sine and the other with just straight sine, those are interchangeable. They mean the same. They are synonymous. So I want the angle whose sine is root 3 over 2. Well, look back up at that triangle. Okay, there is an angle there whose sine is root 3 over 2. Consider the 60-degree angle. From the point of view of the 60-degree angle, the opposite is root 3. The hypotenuse is always 2. So the sine of 60 degrees is root 3 over 2. So we found our angle measure then. The angle measure whose sine is root 3 over 2 is 60 degrees. So that is the answer to our question.